Alright, so now I'm going to break down a couple of tools that I use for sort of weather forecasting, specifically snow forecasting, obviously, because that is very pertinent to skiing. So this is a website called Tropical Tidbits, and if you go to their website under forecast models, this gives you a whole bunch of options on sort of what you can play around with in terms of seeing like data in the forecast. So there are two main forecasts that I use. There's this is a European model, EMC-MWF, and there's a GFS, which is more of a North American model. In general, I would say the ECMWF is a little bit more accurate, but they are both really great tools to use. That being said, there are advantages and disadvantages of both. So like I said, the ECMWF is a little bit more accurate, but the GFS is a 16-day forecast. So you can forecast a lot further out, whereas the ECMWF on a lot of sites is only a 10-day forecast. So I'm just going to use GFS for the purposes right now. And one of my favorite things to do on this site is play around with all the different views that you can have. And the most helpful that I use is this northern hemisphere, at least the purpose that I use this site for. So I'm going to click on Upper Dynamics and 500 millibar geopotential height and anomaly. And so essentially what geopotential height is the height of a certain pressure level. So 500 millibars is the pressure, and this is correlated to the height above the surface. So blue is lower and red is higher. So like the darker blue, see, this is a very low geopotential height, whereas this would be a very high geopotential height. And this essentially, it doesn't exactly correlate to it, but storms are correlated to geopotential height. So the lower the geopotential height, the more likely there is to be a storm. So we can see here there's probably like a storm. This is from a couple days ago because the forecasts do go back up to 72 hours. And there was a pretty decent snowfall in California, and that sort of moved over into Colorado, and lots of places all over the West got snow with that system. So I am going to go, this is current. This is as of about 4 p.m. Pacific time on November 11th. So here's the date up here. There are all these time frames over here, and these are frames. So each frame, if I go to the next one, each frame is about 6 hours, and so it runs throughout the day. So you're able to forecast throughout the day, and essentially what this is forecasting is not exact storms or snowfall, but this is showing you patterns as to where the snow may be heading, right? So if we think about, there's this, a darker blue spot is more correlated with a storm, right? So if we're to run out the forecast, and I'll let these frames render here, but this will essentially tell us where we can expect a storm to form. Not necessarily snowfall, but where we can expect a storm to form, right? So going back and just seeing the overall trend, this storm sort of came into California early on the November 9th, sort of moved across the west, right? We're currently right about here. And so here, even just if the forecast just went out this far, we can see some interesting trends here happening. So you see a sort of a low pressure system forming right here that starts to sweep its way down the coast, and it sort of starts strengthening into this huge, big swath of blue. And then all of a sudden, it seems like the winds sort of cut it more to the east rather than going further south and hitting down the coast. But we can see here a couple of interesting things. So first of all, we can look at the date, sort of night of the 14th. We can expect the Tetons there to get some snow, the Rockies, sort of all the way up the Rockies, sort of into Canada. Parts of Washington get hit a little bit earlier there. Right there, you can see this should bring some pretty decent snow to Washington. Remember, the darker the blue, the better. And so if we remember that, the darker the blue, the better, we can make a couple of observations about this storm. This will be on November 14th through the 15th-ish, and they'll sort of clear out. But we can make a couple of interesting observations about this storm. So first of all, let's say we were interested in just Colorado, and I'll switch views here to a better view if we're focusing on Colorado. Let me pull this up to the continental U.S. Upper Dynamics and 500 millibar height anomaly. So right, if we're just looking at Colorado, this preserves the frame. So we're still on the 14th, right? We can see it's darker the further north you go, and there's sort of this epicenter right here. So the Tetons are going to get hard. But if we're just looking at forecasting snow in Colorado, let's say if I were a Denver weekend skier and this storm were coming in and I wanted to get the absolute best snow I could and I could go to any resort I wanted to, you can see the northern regions of Colorado are going to be favored a lot more in this storm than the southern regions are, right? The southern regions are going to have weaker geopotential height, which is correlated to a higher, right, in meters, higher geopotential height than northern resorts. So northern resorts are going to have a much lower geopotential height and therefore probably a better storm track. So they'll probably receive more snow from that storm. But I really like this tool on Tropical Tidbits because this allows me to see sort of what's happening right in the forecast. So I usually really start paying attention to forecasts sort of 7 days in advance, right? So today's the 11th, so we can sort of trust forecasts almost absolutely, not in terms of exact snowfall, but in terms of where storms are going, sort of up to the 7 to 10 day range. So this is 10 days out, November 21st, and this is where things start to get a little bit sketchy, but we can see basic trends, right? So we can see that there could be a little storm here that gets California, gets the Sierra a little bit, but we can see this storm here, not only does it form very early out here, but it strengthens the further south it goes, right? So it's sort of right there, it makes this big jump and starts strengthening, and then all of a sudden it slams into the coast. So this could be a very productive storm. This is right around Thanksgiving, sort of the 24th, and like most storms, it comes south along the coast and then hooks to the east and starts moving across the Intermountain West, right? So right there, resorts like Snowbird, Alta, Colorado, all the Summit County resorts, everything's going to do very well with the storm if things persist. And that's a very interesting thing to keep in mind, that it's not always accurate this far out. This is 14 days out. This is a full 2 weeks out. So, while there will probably be a storm that week, or within sort of a plus or minus 3 days there, we don't know how strong it'll be. We don't know if it's going to be, the storm of the century and it's going to bring 200 plus inches, or if it's just going to be a little dusting of snow on the mountains. That's something we don't know. But we do know that there will most likely be a storm there in that period of time. And same thing goes for, this next little swath coming in, not as strong as the first one, but still decently strong. So this is a really good long-range tool to just be able to visualize sort of when storms are coming. It doesn't give you a great sense of how strong they are long-term, but short-term, right? If we go here, it's a really good tool because it allows us to see, okay, northern Colorado resorts, or, for example, Grand Targhee and Jackson Hole up in the Tetons, up in Wyoming. Let me actually focus back in on the continental U.S. view. Right, if I were to go to Upper Dynamics, Height and Anomaly, with this storm, this is on night of the 14th, so with this storm, Jackson Hole is sort of situated right in the epicenter here, like the middle of the storm, not quite, but it's going to get a hit a lot harder than, Telluride down in southern Colorado, for example. So if I had the option to go to either Jackson Hole or Telluride for this storm, I am definitely booking a ticket to Jackson Hole. And same thing goes for, storms out in advance. So if we go to that one super far out, this is that one that we were talking about, right? There's not really any clear, it's a pretty long storm, so there's nothing super clear, but that might change in the next couple days. So this geopotential height model is very efficient at sort of giving long-term trends and like a long-term overview of the forecast, but not forecasting specific. So forecasting when and where storms will happen, but not necessarily how strong they'll happen, if that makes any sense. So next, I'm going to go to this other really good model. This is from the College of DuPage. This is their meteorology website. And so I'm going to go, these are all the different models here. So they have a bunch of different models that you can access. Each of the models is good for different things. So like I said, there's accuracy and time frame that the model covers. But another thing that's actually kind of important when forecasting snow is resolution. So resolution essentially means if I'm going to click on this and I'm going to go to precipitation products, total snow accumulation. This is for the entire continental U.S. Or actually, I'll zoom in. I will go select sector view. I'll run over this in a sec, but let's say I go to the end, right? So this is by November 27th. How much snow are they going to get? Now, if I'm going here, watch the frequency in which it jumps. So it jumps numbers there, but it stays for a while, jumps numbers there, right? So that's a huge swath of mountain there that I'm not getting super accurate readings for, right? So you can sort of see this. It almost looks like diamonds, right? There's a diamond there, 16.6. As soon as you exit that, 7.6 and 7.6 all the way around. So it's really not very it's not very detailed in terms of of the resolution you're going to get. Now this other one, this is a very, 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 high resolution forecast. So if I'm select sector view, I'm going to go to the same view as the last one. So this is southwest, precipitation products, and I'm going to select total snow accumulation. This one doesn't go as far out. This only goes a couple days, but you'll see there's super high resolution, right? As soon as I move my mouse, the number is going to change. This is very, very localized forecasting, although it doesn't go very far out, right? This goes, a day and a half out, but this is very, very efficient at forecasting very local events. And there are other sites where you can access this same forecast. This isn't just limited to this website. This is just a way that you can, see the forecast on this website. So this model is very, very good for very short term. Like if I'm in, the Summit County area, which resort's going to do best? And so super, super specific, very high resolution. This is a good model for that. GFS, which is the same model as we were using before. This is a really good model for forecasting big picture snow amounts. Where is going to get the most amount of snow? So I am going to select precipitation products, and this number here. So total snow accumulation. Let's just click on this, right? This number here, the 10-to-1 ratio. That's for every 1 inch of water that falls, there will be 10 inches of snow, and this has perks and disadvantages. That is probably a decent average, a very eyeball amount for most places in the U.S. However, the colder the temperature, the higher that ratio is going to be. And the higher that ratio is going to be, we like to think of that as, better skiing, right? That's that blower, cold smoke, powder that everyone loves. Whereas, an 8-to-1 ratio is sort of the lowest, not the lowest, but a very, very low amount, sort of 6-to-1, and that's where you start to get into the unenjoyable mashed potato-y sort of spring snow. That's really not fun to ski. So there's a significant drawback to, it's good for generalizing and standardizing among weather forecasts, but it's not good in actually predicting the amount of snow that falls, which is sort of counterintuitive, why would they use that? But it is an easy way to standardize it, and it's accurate for most places. But this, the thing I really love, and mainly the reason I use the College of DuPage website for snow forecasts, they have this thing called the Kuchera model. And essentially what this takes into account is temperature and pressure in the atmosphere as you go up into where the snow is forming high up in the atmosphere. And this actually gives you a much more detailed idea of sort of what this snow is going to look like. So let me just zoom in quick. So I'll go to the southwest. This sort of gives California, Utah, Colorado. So pretty good place to test this out. But I'm just going to run, here, and I can select precipitation products, and I'm actually going to select the Kuchera snow ratio. So essentially what this is going to tell me is not the amount of snow that's falling, but the ratio, the density of the snow, right? So this is a 24-to-1 ratio. So this, if snow were to fall here, which it will, it's forecasted to be falling here, this is a very, 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 very light snowfall in terms of the density of it, right? So if let's say in this storm here that's coming over Colorado, 1 inch of water is supposed to fall, with the 10-to-1 ratio, with the assumed 10-to-1 ratio from the model, this would be giving 10 inches of snow. And with 1 inch of water with the Kuchera thing, taking into account the snow ratio, this would be 24 inches of snow. That's a big difference. 10 inches of snow skis a lot differently than 2 feet of snow, right? So obviously, 1 inch of water falling in such a short time period, the storm sort of fleets, but 1 inch of snow falling in such a short time period or 1 inch of water, is very uncommon. So that is a very big storm. But it can still happen. But the thing I like about this is you can really see, Colorado is known for its very lightweight snow. Same with Utah, right? So sort of 20 plus range of snow, whereas California, which is sort of lower elevation, right? So you're getting more into sort of 10 range again, right? And it could get colder, right? Let's see here. If the temperatures get colder, this is dipping into 13 for California here. And then this, when it's totally sort of blank like this means there's just no snow falling, right? But you could see, for this time period, this is going to be very, very, very heavy snow, 4.5-to-1. So for every 1 inch of water that falls, there'll be 4.5 inches of snow. Right here, it's starting to get respectable and a lot colder, and 15-to-1. That's a pretty good snow ratio. That's good skiing. So that's just a way to sort of visualize how lightweight the snow is going to be. Is it going to be Sierra cement, or is it going to be sort of Colorado, like blower smoke powder? So this is an interesting tool to play around with and sort of visualize snow ratio. And so that snow ratio plugs into the Kuchera methods, the College of DuPage's Kuchera method to predict snowfall. So essentially what they do is to say, okay, how much precipitable water, which I'll talk about, or actually I should talk about that first. So precipitable water is essentially how much water is in the atmosphere. How much water, if it were to rain, how much water would come out. So here you have a lot of water, right? 1.3 inches. So if this cloud released all of its water, 1.3 inches of rain, 1.13 inches of rain would fall out of the atmosphere. And vice versa, this very dry air over Colorado, if all of it were to fall in rain, only 0.14, right? So there's a pretty significant difference there. But essentially what the Kuchera method's able to do is take this precipitable water, how much water is in the atmosphere, and multiply that amount of water by the Kuchera ratio that it has forecasted just based on temperature and pressure throughout the atmosphere. And so what you get is this much, much more accurate representation of how much snowfall is going to fall, right? So if I were to compare and contrast this to the 10-to-1 ratio, it would look very different. It's a much more accurate way of forecasting snowfall. And so this is something that this is my if I'm looking to, give someone, if someone asks how much snow is going to fall in Colorado this weekend, this is where I'm going. And this is, I'm using this method, the Kuchera method, because it takes into account snow ratio. So you see here, this is like 20.4 inches forecasted in the next, 2 weeks or so. But this is a very accurate, or not necessarily accurate, but more accurate than the assumed 10-to-1 ratio way of predicting snowfall. So this website also has a lot of other things to play around with. You can still get, humidity here. Which is relatively helpful if you're forecasting, hoarfrost, surface hoar forming on top of the snowpack, which has huge avalanche implications. But there's tons of precipitation products. This is let's see. This is total precipitation, so not just snow, right? But it doesn't specify what type of precipitation is falling, but how much it is. And QPF here, that's that number there, stands for quantitative precipitation forecast. So that's, again, like just snow water equivalent if it's falling as snow, or just how much water is falling. And so you can, if we go to total precipitation amount, we can see here, this is not snowfall. This is instead like how much water is falling. So places like here, this is in the Central Valley of California, not high elevation. It's probably raining here. So this would probably be like 4.64 inches of rain. Whereas in Colorado, they're not getting very much snow. But if you're assuming like a 10, 15 inch, or 10 or 15 to 1 ratio of snow to water, that starts to get into sort of like the 20s, 20 inches of snow. Which, if we go back to, so remember that spot sort of right there in Pitkin County, 1.63, and then we go back to the Kuchera snow accumulation forecast, all the way to the end, 22, that's about 15 to 1 ratio. So the Kuchera method actually does a pretty good job of taking into account like precipitation versus snow ratio, and gives you a really good estimate for sort of what's going to fall. But this total precipitation accumulation is very helpful for avalanche forecasters, and more so than that, it's 24-hour precipitation accumulation, because if you're having a significant loading event, right, in the Wasatch here, let's say there was a layer of hoarfrost and there's a ton of snow coming down, right? This could be, a foot of snow in 24 hours. But more importantly than snow, it's not about the amount of snow that falls. It's the snow water equivalent that falls. So how much water is falling, and that's where we can get from this 24-hour precipitation accumulation. This is going to tell you like how much weak layers are being loaded, and from that you can sort of deduce like what is the avalanche risk today? How likely is that weak layer to fail? But obviously, if you're going into the backcountry, always read the avalanche forecast before you go out, because these are guys who know their stuff about meteorology and snowpack, and that is a much safer way than trying to do it by yourself. So I hope that sort of gives you a nice overview of how to use these tools to do some like very basic forecasting. It's something that I've had a lot of fun sort of learning how to do, and it's cool to share that with others. But I hope you enjoyed this, and I will see you later if I do more forecasting things. So yeah.